Hello friends, let us study about lipids. Lipids are defined as substances which are insoluble in water but soluble in solvents of low polarity like chloroform, carbon tetrachloride and ether. They are widely distributed in nature but rarely occur in an organism in the free state. They occur in combined state with proteins, that is lipoproteins, or carbohydrates, that is glycolipids or lipopolysaccharides. The greatest amount present in food in the form of fats and phospholipids. Fats and oils may be obtained from vegetables, that is various vegetable oil, cocoa butter, etc. From animal sources like milk fat, lard, tallow, etc. Lard is pig fat and tallow is beef fat or mutton fat. And from marine sources, that is whale oil, cod liver oil, etc. Classification of lipids. Lipids can be classified on the basis of its complexity, ability to react with alkali to form soap, that is the process of saponification, and based on the polarity, that is charge on its components. Based on structure or complexity, lipids can be classified into three groups, that is simple lipid, complex lipids, and derived lipids. Simple lipids. These lipids are composed of fatty acids and alcohol components. Example, fat, oil, and waxes. They can be hydrolyzed to two different compounds, usually alcohol and an acid. Compound lipid. These lipids include phospholipids, steroids, carotenoids, etc. On hydrolysis, it yields three or more different compounds. Derived lipids. They meet the definition of a lipid but are not simple or compound lipid and include fatty acid and alcohol, which are the building block of simple and complex lipids. It also includes sterols, vitamins, pigments, hydrocarbons, etc. Fat soluble vitamins like vitamin A, D, E, and K are included in derived lipids. Based on the polarity, lipids can be classified into two, that is polar lipids and non-polar lipids. Polar lipids, they are charged molecules soluble in polar solvents like alcohol, acetone, etc. Example, phospholipids, glycolipids, fatty acids, etc. Non-polar lipids, they are uncharged molecules soluble in non-polar solvents like ether, benzene, hexane, etc. Example, glycerides, sterols, sterol esters, carotenoids, waxes, vitamins, etc. Based on saponification. Lipids are classified based on the ability of lipids to react with alkali to form soap. The process is known as saponification. Based on this reaction, lipids can be grouped into saponifiable lipids and unsaponifiable lipids. Saponifiable lipids. They react with alkali and form soap. They are present in large amount. For example, glycerides, phospholipids, fatty acids, cholesterol ester, etc. Unsaponifiable lipids. They do not react with alkali to form soap. They are present in relatively small amount. For example, fat-soluble vitamins, sterols, hydrocarbons, carbonyls, etc. Role of lipid. They serve as a fuel molecule. 1 gram of fat provides 9 kilocalorie of energy, that is more than twice as much energy as protein or carbohydrates. Lipids supply 20 to 30% of total calorie requirement. Fat also contributes characteristic flavor and aroma to food and produce a feeling of satiety or loss of hunger. Phospholipid and triglycerides are important to structure, composition and permeability of cell wall and cell membrane. Lipoproteins help in transporting lipids in blood. Fat present in food help to carry fat-soluble vitamins so that they are efficiently absorbed. Skin waxes act as a defense mechanism in avoiding thermal and physical shock. When energy supply from food is in excess of energy demand, the excess is preferentially stored as fat in adipose tissue. As a storage fuel, fat have an advantage as they can be stored in anhydrous form while glycogen, the stored polysaccharide, is heavily hydrated. Fatty acid. Fatty acids are long-chain carboxylic acid. General formula of fatty acid is CH3, CH2N, COOH. Most of the fatty acids contain even number of carbon atoms because of the way in which they are synthesized in living beings. But few fatty acids are present which have odd number of carbon atoms. Most of the fatty acids found in nature are linear, but few branched chain and cyclic fatty acids can be also found. Saturated fatty acid. Straight chain fatty acid containing 2 to 80 carbon atoms are known, but in food those having 4 to 24 carbon atoms are present. The largest share is of fatty acids containing 16 and 18 carbon atoms. Fatty acid with carbon atoms 4 to 10 are present mainly in milk fat. Characteristic fatty acid present in milk is butyric acid that contain 4 carbon atoms. Fatty acid having 12 to 24 carbon atoms are present in vegetable and animal fats. Fatty acid having greater than 24 carbon atoms are found in waxes. In food, lauric, myristic, palmitic and stearic are the most common acids which are present. Name and structure of saturated fatty acids found in food are given. The 4-carbon fatty acid, that is butyric acid, is most abundantly present in milk, and the 12-carbon saturated fatty acid, lauric acid, is present mainly present in coconut oil. Unsaturated fatty acids. Unsaturated fatty acids are fatty acids which contain double bonds between the carbon atoms. Unsaturated fatty acids may have 1 to 6 double bonds. They are subdivided into two types, MUFA and PUFA. MUFA means mono unsaturated fatty acid and PUFA is poly unsaturated fatty acid. Most of the naturally occurring unsaturated fatty acids are cis isomers. Some unsaturated fatty acids found in food, their common name and numerical abbreviation. This implies oleic acid contains 18 carbon and it is having one double bond. Similarly, linoleic acid is having 18 carbon atom with 2 double bond. Linoleic acid with 18 carbon atom and 3 double bond. Arachidoic acid with 20 carbon atom and 4 double bond, and so on. DHA is having 22 carbon atom with 6 double bond. This is an excellent source of DHA is excellent source of omega-3 fatty acids. Essential fatty acids. Certain fatty acids like linoleic acid are necessary for maintaining health conditions of animal. In plants, these acids are formed from oleic acid, but animals lack necessary enzyme for their synthesis. Therefore, they must be supplied from diet and are known as essential fatty acids. Triglycerides. Triglycerides are carboxylic esters derived from glycerol. Glycerol contains 3 OH groups which can form ester linkage with fatty acid. If one OH group is esterified, the compound is called monoglyceride. If two are esterified, diglyceride, and if all 3 are esterified, the compound is designated as triglyceride. The structure of glycerol, monoglyceride, diglyceride and triglyceride are given. Phospholipids. In phospholipids or phosphoglycerides, one of the terminal OH group in glycerol is esterified by phosphoric acid and the remaining 2 by fatty acids. Phospholipid contain choline is called lecithin. It is very good emulsifier and is present in egg yolk. That is, lecithin is present in egg yolk. Phospholipids are components of cell membrane and influence its structure and function. They help in transporting other lipids in the blood. The structure of phospholipid, that is lecithin, is given. Rancidity. Lipids undergo chemical change which leads to undesirable odor and flavor. This process is known as rancidity. There are two types of rancidity, that is hydrolytic rancidity and oxidative rancidity. Hydrolytic rancidity is caused because of hydrolysis and oxidative rancidity by oxidation. Hydrolytic rancidity is also known as lipolytic rancidity, is the rancidity developed by the hydrolytic reaction in which the lipids are hydrolyzed to yield glycerol and fatty acid. This reaction can be catalyzed by acids, bases, enzymes or heat. If reaction is catalyzed by base, salts or fatty acid are obtained and this reaction is known as saponification. Lipolysis depresses the smoke point of cooking oil and as a result cooking quality of fat is lost. Because the foods fried in such oils absorb greater amount of fat and the frying quality is also degraded. Oxidative rancidity. It is the rancidity developed when fat react with oxygen in air or oxygen producing products. In oxidative rancidity, a large number of intermediates are formed and compounds produced by their condensation are responsible for rancidity. This rancidity is catalyzed by heat, light, ionizing radiations, and enzymes. This type of rancidity can be prevented by adding substances like antioxidants. That's all. Thank you.